Let's dive right into this explainer and completely elevate an incredibly mundane, everyday object into something truly awe-inspiring. Seriously, we all have one sitting on our desk right now, maybe shoved in a drawer or tucked behind an ear. But how often do you actually stop to think about the incredible journey it took to get there?
Today, we'll be covering billions of everyday pencils, the myth of pencil lead, the factory sandwich process, making DIY pencil lead, and finally, crafting your own casing.
Okay, part 1. Billions of everyday pencils.
14 to 20 billion. That is the mind-boggling number of pencils produced globally every single year. I mean, it's almost hard to wrap your head around a number that large. It totally proves that despite all our smartphones and digital tablets, this simple little tool is still universally essential.
To meet that immense demand, the world's top pencil producers, which are primarily China, the USA, and Brazil, rely on some seriously heavy-duty, highly efficient industrial facilities. The efficiency they achieve is just incredible. Get this, just one single ton of wood yields 30,000 custom pencils. It takes these massive, specialized factories churning through actual mountains of materials to meet the demand, which really sets the stage for some heavy industrial magic.
Moving on to part 2, the myth of pencil lead.
All right, we need to immediately address the elephant in the room here. The crucial point is that there is absolutely zero actual lead in your pencil. None. It's entirely graphite. Graphite is a soft, black form of natural crystalline carbon extracted from deposits that are literally millions of years old. The whole confusion started way back around 1564 when a massive, high-quality deposit was discovered in England. People originally used it to mark their sheep, of all things. And, well, because it looked a bit like lead, the misnomer was born and just kind of stuck. But the science tells a completely different story.
Have you ever wondered what the HB on your pencil actually stands for? It all comes down to some brilliant chemistry pioneered back in the 1790s. A French scientist named Nicolas Jacques Conté figured out that you can perfectly control a pencil's output just by mixing graphite and clay. The graphite provides the blackness and the softness, that's the B grade on your pencil. The clay provides the hardness, the H grade. It's just perfect, simple chemistry.
Which brings us to part 3, the factory sandwich process.
So how do they make them? Well, the first step is honestly pretty brutal. Factories mix graphite powder, china clay, and water into this thick, gray sludge. Getting this consistency perfectly right actually takes a full week. Then heavy machinery extrudes this paste into thin rods under nearly 10 tons of pressure. Finally, they are baked in a kiln at up to 1,000 degrees Celsius. That is over 1,800 degrees Fahrenheit. These fragile little rods are blasted with intense pressure and extreme heat just to survive being written with.
Meanwhile, the wood needs preparing too. Factories typically use durable, lightweight woods like incense cedar. They carve tiny grooves into thin wooden slots, apply a special polyvinyl acetate glue, and lay the fragile graphite rods inside. Then, a second grooved piece of wood is placed right on top, and they are pressed together under a massive 1,000 kilograms of pressure. This creates what's affectionately called a sandwich block, seamlessly encapsulating the fragile graphite between durable, defect-free cedar wood. To finish the whole process up, heavy industrial saws slice that sandwich block into up to 10 individual, perfectly uniform pencils. They get sanded down, coated with anywhere from 2 to 8 layers of safe, water-based paint and varnish, and finally, a metal ferrule is crimped onto the end to hold your rubber eraser. Going from a giant wooden sandwich to perfectly uniform, toxic-free lacquered tools, the factory process is just a total marvel of precision.
Now, let's switch gears for part 4, making DIY pencil lead.
You can actually do this yourself, and you should think of it like a quick cooking recipe. To make your own lead, you just need 1 part, so say 10 grams, of non-toxic graphite powder and 2 parts, or 20 grams, of air-dry clay. Simply mix them together, add a few drops of water if the clay gets too dry, roll the mixture into a rod shape, and just let it sit for 24 hours. By mixing safe graphite powder and air-dry clay, you get to bypass those crazy 1,000-degree ovens completely.
And you know what the most fascinating part is? This raw, chunky, totally homemade mixture leaves the exact same marks as a factory pencil. Despite not being compressed under 10 tons of industrial pressure, this accessible DIY science works perfectly. It's literally chemistry in action right on your kitchen table.
Finally, part 5, crafting your own casing.
Once you have your lead, you need a way to hold it. We have 2 amazing options here that completely contrast the heavy industrial saws of a factory with some charming kitchen table crafting, the paper pencil method and the twig pencil method. Let's break them down.
So, the paper method is highly eco-friendly and super satisfying. You just take a square of origami paper, generously coat the inner side with Mod Podge adhesive, and tightly roll your lead inside it. The absolutely crucial part here is applying firm pressure to avoid any gaps between the layers. Once you let it dry out on the sun, the adhesive turns that flexible paper into a stiff, carvable casing.
Alternatively, the twig method really grounds the experience in nature, swapping out massive cedar logs for a simple branch right from your backyard. You trim a straight 5-inch branch, dent the center with an awl, use a 3/32" drill bit to hollow out a 1.25-inch hole, wedge your glue-coated lead inside, and just whittle the tip. It's such a rustic, brilliant way to connect with the raw materials of writing.
So here is my final question to you. Will you ever look at your everyday stationery the exact same way again? And are you brave enough to try baking your own writing tools this weekend? By understanding both the massive global scale and this accessible DIY science, I really hope this explainer inspires you to get hands-on. So grab some clay, grab a twig, and start creating.